Duke Energy is one of the largest electric power holding companies in the United States, with services ranging from renewable energy generation, natural gas distribution, to transmission services. Partnering with UNC Charlotte, they have identified that the growth of electric vehicles will account for at least 35% of the world's new vehicle sales by 2040 and want to facilitate this growth. Some barriers for adopting this new technology include cost, limited range, availability of charging stations, charging time, and apprehension of using new technology in charging stations. It's important for new users to have an easy and simple approach to this, as it will be vital for large-scale adoption of electric vehicles. Duke Energy wants its customers to park at a station, plug in their vehicle, and have transactional information occur without the customer's involvement, hence the title, Frictionless. Meeting with our technical coordinators from Duke Energy, we identified that operating at low peak hours would be ideal to reduce strain on the grid. They also emphasized the importance of a quick interaction, where once the user has plugged the charger into the car, no additional steps would be necessary in order to process the correct billing information, as well as creating a system in the case a vehicle were to collide with our charging station. We concluded that adopting an RFID identification system allowed for the user to have the simplest interaction after initial setup. The user would place a tag inside the charging port so that once they plug in the charger, the modified handle would be able to communicate to the system which car is being used and how they will be billed accordingly. We also created a breakaway system. In the case that a vehicle collided with our unit, we machined bolts down to a 3/8" diameter at the location of shear, allowing the system to break away if the vehicle were to collide with the unit up to speeds of 10 miles per hour. This is attached to the bottom flanges of our entire housing unit, consisting of an enclosure, stand, and flanges. Using an open EVSE kit, we modified the code to include the RFID system, an LTE system, and an Arduino to transmit and receive information. We were able to test our prototype at Duke Energy's testing facility at Mount Holly. There, we were able to verify electric flow within our system and usage of the charger modification to account for the RFID. Overall, we were able to complete a prototype that is able to supply charge to an electric vehicle with the added modifications of RFID and LTE, as well as a housing unit that is capable of breaking off under the necessary conditions. We look forward to how Duke Energy will build upon this current prototype to ensure the frictionless approach we took upon for this project.